y equal to fx, and this boundary is x equal to a, and this boundary is x equal to b. Okay, if we divide this segment of line from a to b in infinite small segments by straight line, those are parallel to this y-axis. Okay, like this. In small infinite segment, and width of each segment is, let's h. Okay, so if we divide it into n segment, n small segments, okay, from point A to point B. So here we have n small segments starting from point A to finishing at point B. Okay, so we need to calculate area under this curve. So how do we calculate area under this curve? By using this approach. Okay, we are dividing this area into small segments so that we can consider this a narrow strip as a rectangle. Okay, so if I write this point is x equal to a, and this point, what will be the value of this point? X1. Okay, so value of this x1 will be a plus, that is increment of h. We can write a plus h. Okay, so here the value is f of a, and here the function value will be f of a plus h. Okay, and this point the function value will be f of b. Okay, if we add all these small area from starting from a to ending at point b. Okay, similarly we can say the whole area, that is integral from point a to b fx dx is equal to sum of all these area. Okay, so we can write h into f of a plus f of a plus h up to last point f of b. Okay, in this way we can write like this equation. If I consider this is narrow strip as a rectangle. Okay, so the width is h and height is f of a, f of b, like these points. So this area is equivalent to this area. And what is the value of h? Can you find the value of h? Anjita, can you find value of h from this integration point of view? Anjita, are you following this area integral? Okay, so can you tell me how to find the value of h? Because I can write the point B is nth point. So I can write B is equal to A plus n times h, isn't it? By simple use of the increment h every times, and there are n segment here. So I can write point B as like this. So from this equation, I can write B minus A divided by n is equal to h, isn't it? Can I write like this? Okay, if I substitute this h value here, then this integral a to b fx dx can be written as b minus a divided by n. This is, can I write like sigma of fxi? These points are starting from I 1 to n. Can I write like this, the sigma of this? Because this is, because if I put 0, then I get f of a. If I put 1, then I get this value as f of a plus h, and last point will be f of b. Okay, so if I apply limit as a n tends to infinity, then here if I apply a limit n tends to infinity, if we consider there are infinitely small and there are many steps inside this area. Okay, so these two area are equivalent. Okay, so this equation is considered as integral equal to sum as a limit, area as a limit. Okay, so based on this formula, there are lots of questions asked in JEE means examination. Okay. So how to reverse if this equation is given? So how to consider a limit into integral? Okay. So several times we have given the equation like limit n tends to infinity 1 by n f of r by n, here sigma function. If we convert this integral into this limit into integral, so we can write r by n value as a x, 1 by n value as dx, and sigma value is replaced in integral. So I can write this limit as 0 to 1. This is fx and this is dx. So using this equation, there are lots of questions asked in JEE. Okay. So let us try to solve some question based on sum as limit. Okay. So my first question is limit n tends to infinity 1 upon n plus 1, n plus 2 plus 1 upon n plus 2, n plus 4 up to last point is 1 upon 6n square. So can you formulate this equation with the help of this, Anjita? Can you convert this limit as a sum in integral equation? Do you know how to solve this kind of question? Converting into this equation. Because every time one question is asked on this strategy, basically this integral equation. How do you formulate this equation? Here outside there is a 1 by n. Okay. So if I write limit n tends to infinity, here 1 by n. Okay. If I check the n plus 1, n plus 2, so this is increasing 1 by 1. Here increasing 2, 4 like this way. So can I write this is the sigma of 1 upon n plus r, n plus 2r. Here r equal to 1 to n. Can I write like this? This whole equation can be written like this. Anjita, are you following this? Okay. So if I write the whole equation in form of sigma, so now if I check, if I take n as a common from these two, so what will be outside? How do you formulate this equation now? So if I take n common from this factor and this factor, so I can write n sigma of r1 to n 1 upon, if I take n common, then 1 upon r by n, and n from this factor 1 upon 2r by n. Okay. So this n get cancelled, and this is finally limit n tends to infinity sigma of r1 to n, and this is 1 upon 1 plus r by n, 2r by n, and this is 1 by n. Okay. If I make the substitution, 1 by n is converted into dx. Okay. R by n is converted into x. Okay. And this whole sigma is converted into integral. Okay. So if I substitute all these values, then this equation, sigma equation, is converted into integral 0 to 1. Okay, 1 upon 1 plus x, 1 upon 2x, and this 1 by n, this value 1 by n equal to dx. Okay, so now can you calculate this integral value by using partial fraction? Can you calculate this integral value using partial fraction? Okay, if we use partial fraction here, then we can write a upon 1 plus x plus b upon 1 plus 2x. That must be equal to 1 upon 1 plus x and 1 plus 2x. Now we need to find the value of a and b. How to find value of a and b? Taking the LCM here, we have 1 plus x, 1 plus 2x, and this value will be a plus 2ax, b plus bx. Okay, so here I have 1 plus x and 1 plus 2x. Comparing both sides, now what is the constant term this in this equation? So I have 2a plus b into x, a plus b. Okay, so here 0 into x. So if I compare from both sides, 1 plus 0 into x, then a plus b should be equal to 1 constant term, and equal to 0. If we solve these two equations, so we have a equal to minus 1, and if I substitute a equal to minus 1, then b equal to 2. Okay, now substituting the value of a and b in this equation, partial fraction equation. So I can write integral 0 to 1 dx 1 plus x 1 plus 2x equal to a upon a value is minus 1, so minus 1 plus x plus 2 1 plus 2x 0 to 1 into dx. Now if I distribute this integral here, then we have 0 to 1 minus 1 upon 1 plus x into dx, isn't it? Plus 0 to 1 2 upon 1 plus 2x into dx. Okay, are you following up to this, Ankita? Are you following up to this or not? Okay, so what is the integral of this term? So minus 1 log of 1 plus x, and our limit will be 0 to 1 plus this will be twice log of 1 plus 2x divided by 2 because of this factor, and limit will be 0 to 1. Okay, so now if I calculate this integral, this is minus of log 2 minus 0, this 2 get cancelled, and this will be log of 3 minus 0. Okay, so this is equal to log of 3 plus and minus log of 2. So that can be written as logarithm of 3 by 2. This is the final answer. Okay. So this kind of questions are asked several times in JEE. Okay. So let us try to solve some more questions based on this approach. So next question is, okay, so can you calculate this? Using the same approach, limit as a sum, can you calculate this? Try to calculate this. Okay, so we have sigma of k equal to 1 to n, limit n tends to infinity, k by n square plus k square. Okay, if I take n square common from this denominator factor, then I have sigma of k 1 to n, limit n tends to infinity, k divided by n square 1 plus k square by n square, isn't it? Okay, so now if I convert this limit into integral, then we have to consider 1 by n as a dx, k by n as x, and this sigma into integral. Okay, so this limit will be converted into 0 to 1. Okay, so here if I break this, so here one factor is k by n and there is also one n. So I can write x upon 1 plus x square into dx. Okay, so now can you calculate this integral value? Anjita, are you following or not? Is there any problem? When is your JEE name date? Okay, network is slow. Okay, fine. When was your JEE name date? In February attempt. When will be your JEE name? Your JEE main dates for February attempt. Okay, 26th. Okay. Have you revised the basic things and formula and all those things? Okay, fine. Okay, fine. So there may be a question from this segment. Always, if I look at the paper of 19 and 2020 JEE mains, so there is always a one question in lot of sets. The question is asked on sum as a limit. Okay, so there might be a chance in this attempt. Okay, so try to understand this concept. Okay, so now if we calculate this integral, how to calculate this integral? Can we use substitution now? Because if I substitute 1 plus x square as a t, then I have 2x dx as a dt. And what is the change in limit? Change in limit, if x is 0, then t equal to 1. If x is 1, then t equal to 2. Okay. So if I change this integral by substitution, then limit will be 1 to 2. And this is dt by 2, and this whole is t. Okay. Now if we integrate this is 1 by 2. And this is integral of 1 to 2 dt by t. What is the integral of dt by t? What is the integral value of dt by t? What is the value of this integral? 1 by x into dx, basically 1 by t into dt. This is ln, isn't it? So we can write 1 by 2 log of t and limit as 1 to 2. Okay, if we calculate this, then we have 1 by 2 limit of log 2 and logarithm 1 is 0. So our final value will be 1 by 2 log of 2. This is the final answer for this question. Okay. So there is one more question based on same kind of approach. Okay, try this question. This is limit n tends to infinity 1 square plus 2 square plus 3 square up to n square into 1 cube plus 2 cube up to n cube sigma. Okay, divide over 1 to the power 6, 2 to the power 6, 3 to the power 6 up to n to the power 6. Can you calculate this limit now using the same concept? How do we calculate this limit now? Okay, if I write this equation, this is sigma n square. So can I write like sigma of r square? And this is sigma of r cube divided by sigma of r to the power 6 and limit n tends to infinity. Okay, can I write like this equation where r starting from 1 to n, in this r starting from 1 to n. Okay, so can I write like this sigma as sigma r square, this equation as sigma r cube, and this denominator is sigma r to the power 6. Okay, so if I simplify this now, This is sigma r square if I divide it by n square. Okay. Here sigma r cube if divided by n cube. Okay. So in denominator we have sigma r to the power 6 divided by n to the power 6. Okay. But here we have n to the power 5. Here we have n to the power 6. So there must be 1 by n some extra value. There is 1 by n some extra value always. So we can say to balance the n power, here 1 by n, 1 by n and 1 by n. Now if we look at the overall power, so what is the power of n in numerator and what is the power of n in denominator? So here 3 plus 2, 5, 6 and 7 in numerator, and here we finally have 6 plus 1, 7. So overall power of n is balanced now. Okay. So if we convert each sigma into integral, then this integral can be written as 0 to 1 x square into dx, and this integral can be written as, this sigma can be written as x cube 0 to 1 into dx, and this whole integral in denominator can be written as 0 to 1 x to the power 6 into dx. This whole sigma is converted into integral equation now. If we calculate this integral now, this is x cube by 3 limit 0 to 1. This is x to the power 4 by 4 limit 0 to 1. And this is x to the power 7 by 7 limit 0 to 1. Okay. So finally we have 1 by 3 minus 0 into 1 by 4 minus 0 divide over 1 by 7 minus 0. Okay. So in numerator we have 1 by 12. In denominator we have 1 by 7. So finally we have 7 by 12 as the answer. Okay. So this is our final answer. Okay, this is all about sum as a limit, and we have solved lots of questions. So this is the approach to solve sum as a limit questions. Now if we move on, properties of definite integral. What is the first properties of definite integral? What is the properties of definite integral? So first property is, if I have area above x-axis, that is positive. If I have area below x-axis, that is negative. Okay, so let's suppose this area is A1, this area is A2, this is A3, and this is A4 from point A to point B. Okay, so if I write integral of A to B fx into dx, then this A, in terms of area, we can write A1 minus A2 plus A3 minus A4. This is the area integral. Okay. So this is the first property of area. And what is the second property? If we need to calculate instead of this definite integral, if we are asked in question to calculate the area, then we have to consider each area in absolute term. Okay, if someone asks area from point A to B, then we have to consider each area positive. Okay, if someone asks for definite integral from A to B, then we have to consider area with sign. Okay, so above x-axis positive sign, below x-axis negative sign. Okay, so if someone asks, this is, let's suppose y equal to fx, area under the curve y equal to fx from x equal to a to x equal to b. Then we have to consider each area with absolute sign, plus sign. Okay, so then we have to add each area at mode of a1, mode of a2, plus mode of a3, and plus mode of a4. Okay, if area is asked in the question. Okay, if definite integral is asked, then we have to consider with sign. Okay, this is clear to you? This is clear to you, the difference between area and definite integral. Okay, fine. So next property is integral a to b fx into dx is equal to minus of integral b to a fx into dx. This is the next property. Okay, if we change limit from a to b into b to a, then this integral will be negative. Okay, and third property is, if I have integral a to b fx into dx, and in between, if this function is continuous, let's suppose this is fx and this point is a and this point is b, and there are lots of points in between like c1 and c2, then we can break this integral as a to up to this point c1 fx dx, from c1 to c2, from this point to this point fx into dx, and plus c2 to final point b fx into dx, if fx is continuous and we have lots of integral, so we can break like this. Okay, this is the third property of integral. Okay, so based on this property, let us solve some question. So first question is, calculate the area, calculate the integral of -1 to 2 mod of x cube minus x into dx. Can you calculate this integral from -1 to 2 mod of x cube minus x? Take your time and try to solve this sum. Okay, how to open this mod? How do you define this function in from -1 to 2? We have mod of x cube minus x. Okay, so if I take x common, then I can write mod of x square minus 1 like this. Okay, so if I factorize, then this equation is x x minus 1, x plus 1. Okay, if I check sign of this expression, so we have here minus 1, 0, and plus 1. So this equation is positive from 1 to infinity and negative from 0 to 1, and again positive from minus 1 to 0, and in this part this is again negative in this part. Okay, but we have to consider only from minus 1 to 2. So up to minus 1 to somewhere there is a point 2. Okay, so if I consider for this first interval minus 1 to 0, what is the sign of this? Positive. So we can open this mode directly, isn't it? When mode value is positive, so there is no need of minus sign. So we can say when x value is minus 1 to 0, so we can write this mode value as directly x cube minus x into dx plus. Now from 0 to plus 1, 0 to plus 1, this mode value is negative. So we need to multiply with minus sign to open this mode value. Okay, so we can write from 0 to 1 negative of x cube minus x into dx plus from 1 to 2, this is again positive, so we can write this mode value as x cube minus x into dx. Okay, can we write it like this? This mode equation can be opened like this. Are you following? How to open mode equation? Okay, now if we integrate this first integral, so integration will be x to the power 4 by 4 minus x square by 2 from g minus 1 to 0, the limit of this integration. Second integral will be, if I multiply this minus sign, then x to the power 4 by 4 plus x square by 2 0 to 1 plus, then this integral will be x to the power 4 by 4
You are currently the only person in this conference.